Welcome to the new lesson, and in this lesson we will discuss the graph. A graph is a data structure which is consists of nodes and connection between those nodes. Like here in this picture you see that there are three graphs, and every graph has nodes, and those nodes are connected by edges. Generally we can say a graph is a collection of nodes connected by edges, like you see them in picture. However, in this lesson, we will go through graph representations and graph traversal. As we see in the picture, uh, graphs are made up of nodes and the connection between those nodes. So it's important for us to know how to represent these nodes in programming. Uh, like in previous lessons, we studied about tree and linked list, and we were able to represent them in the programming, and then we were able to uh, do some operations with those data structures. Graph is also similar to them. As soon as we learn how to represent graph in programming, then if we know the programming language, we are going to go ahead solving any relevant problem to the graphs. So when it comes to graph representations, there are there are several ways to represent the graph. Like you can represent the graph based on your programming skills. But generally, there are two main ways to represent a graph in programming. Uh, and those two common ways, one of them is the adjacency list representation, and the other one is adjacency matrix representation. Now let's go through these two approach that how do they represent a graph. So now you see three graphs in picture here. Let's see how do we show these graphs in programming using adjacency list. So an adjacency list stores a list of neighbors for each vertex or node. As far as we are writing our code in JavaScript, you should know that the adjacency list is a way of representing a graph in code with an object. It is the one of the most important thing that you should know. When we want to represent a graph using adjacency list, literally that means we are creating an object, and then you know that object in JavaScript is like they have key value pairs that is made up of key value pairs. That means it has a key and it has a value. It has a key, it has a value. Similar to dictionary in Python that we have. So here you see, for example, graph 1. Graph 1 has three nodes. So if you want to work with this graph, first of all, you should write this graph in a programming language. So you should know how to write that. And if you are using adjacency list, then that means you are creating an object, and then all the nodes they can work as the key of that object, and the value of those keys are all the neighbors of that key node. For example, in this example that is displayed or represented here like this, graph 3. First of all, we know that we have like 1, 2, 3, 4, 5, 6 nodes. So that means we put all the 6 nodes as a key in the object, and the value of those keys are a list of other nodes which are neighbors of that key node. That is why we say adjacency list. Adjacency means neighbor. Adjacency list means list of neighbors. For example, key A. What are the neighbors of node A? We can see that A points to E, A points to C, A points to B. So that means A has three neighbors or three adjacent nodes, and they are represented in a list like this. However, you should know one thing which is very important, that these edges have a direction at sometimes. Sometimes you see that edges do not have direction. It means if it has a direction, it is clear that one node can have connectivity to a second node, but that second node may not have a connectivity to the first node. For example, here, F has a connectivity to E, but E doesn't have a connectivity to F. The best example to present this scenario is the follow and followers on social media. For example, if person A or if user A follows user B, that doesn't mean that user B also follows A. For example, when you are on Twitter or X, when you follow Elon Musk, that doesn't mean that Elon Musk also follows you. So in that scenario, you may see a direction that only one node follows another node. So the other thing, for example, here we have node B, and here you see that B doesn't have connectivity to any node. Like I said, A has connectivity to B, but B doesn't have connectivity to A. Like I said, A follows B, but B does not follow A. So here you see that the list of adjacent neighbors for the node B is an empty list, because B does not have connectivity to any node. So now you know that it is an object in JavaScript. So if you know how to work or how to deal with object in JavaScript, that means you are able to work with graph. Okay, so it was one way to represent a graph using adjacency list, and in JavaScript we use object to create that adjacency list. And the other approach is adjacency matrix. That means we create a two-dimensional array to equal to the number of nodes. The size of the array should be the number of nodes. For example, here we have 3 nodes, so that means we can create a two-dimensional array that its row and column is 3. So like here I have written A, B, C. That means node A, node B, node C, and node A, node B, node C. So now whenever those nodes on this array comes to together or cross one another, we put a value 0 or 1. If we put 0, that means those nodes does not have connectivity to one another. But if we put 1, that means those nodes have connectivity to one another. Like here you see A to A doesn't have a connectivity, but A to B has a connection. Here you can see A has a connection to B. Here also it shows A has a connection to C. You can see A has a connection to C. Here B has a connection to A. It shows B has a connection to A. So it is the second approach that we can represent a graph in programming. Now it is a two-dimensional array. So if you know how to deal with two-dimensional array, that means you are able to work with graph problem. Or here in this graph, see here it is represented using an adjacency list, represents relationship as an object data type, and here it is represented as two-dimensional array. So now if you are comfortable either with object or with array, then you can solve any problem relevant to the graph based on your knowledge of object and array. So in the next lessons, I will explain graph traversal algorithms because as you see here, uh, if you know how to traverse a graph, learning those algorithms, which are optimized algorithms, they can help you uh, like traverse a graph easily. Otherwise, based on your knowledge of object and math arrays, you are good to go ahead and solve any problem or challenge relevant to the graph. Until then, have a nice time, everyone.